So our plan is to take the safety box out and then do some checks while we have it on the bench, and then hopefully we'll have a better understanding what did trigger our error code. Today is another e-tron in the workshop, and question mark because it's an auction car. Now, it seems that the car it's in exactly the same state I was purchased from auction, and it was on runner. Big question mark. Why? From the information we've gathered from the customer, they have concluded that he might have been involved in an accident. However, no signs on the bodywork. Well, yeah, I can see probably little things, little scuffs in here, but no signs for anything major outside, no signs inside, apart of the high voltage malfunctions error. And we have no battery, so we had to have a booster. And now we're going to push it inside to see exactly what made this e-tron not to run. Follow me. Fast, very fast, and a very heavy steering wheel. Hello from OGS Mechanics and OGS Mechanics Hybrid and EV. I'm George, and here in our workshop we fix cars. All types of cars, but mainly specializing in hybrids and EV vehicle like this. Stay close for interesting repairs translated in videos. So from the inside, everything looks okay. No airbag deployed. Mileage is quite low, 9,800. Switching on the ignition, electrical system fault. We do have a bit of charge, 18% in the battery, so it's good that the high voltage battery is not low on charge. But let's see exactly what is that error code and why the ready light doesn't come on and the electrical system fault stays on. We have already run some checks on the car. First of all, read battery stats, and the battery seems to be in good condition, and then move on to the electrics to see exactly what error codes we have permanent and where exactly we're going to start. So we have hooked to the car now the Audis, which is the software for the original software for VAG group. And our error code is this one over here. So the hybrid EV battery system pre-charge current too high. Now, this is a permanent error, and it clears as soon as you cycle the ignition, it comes back on again. Now, we've done a few checks because it could always be just a resetting, just a phantom fault. Is not the case in this situation. Now, from the checks that we've done, it looks like there's a problem on a high voltage circuit, and we have a high current when we shouldn't do. And what we have here, and Della is drawing on the board. How are we getting on, Della? Yes, fine. I think we have, because the rest is not important. Our focus in here, so this is the high voltage battery, and the circuit that we are concentrating on is this one over here. So we have two relays. This is the positive terminal of the battery, this is the negative, and this is the pre-charge relay. Now, the way those relays work, they switch on one after the other. So first of all, the pre-charge relay switched on. Here is another relay. Sorry, is not drawn as a relay. So when this closed, it's doing a check on the system, and normally it shouldn't see any current. Now our error says that the current is high on a pre-charge, and what this tells me is that this relay, it's stuck on. It's a bit strange. The car only has 9,000 miles, but based on the on this error code and what we've checked, it looks like that is stuck on. And we've done another test, and we're also going to do now. Lal, yeah, we can do it. So what we do, we cycle the ignition. Obviously, with the dealer tool, it tells us to use a special equipment, which we don't have in order to do this test. But if we think a bit outside the box, we can do things differently, still in a safe manner. So what we do, we are measuring here. So in here, this is the output from the battery towards all the electrics of the car, towards the electric motor, towards the AC, and so on. And what we've done, we went to a point, and then we cycled the ignition. And if my theory was right, we should have voltage for a split second, and then it should go off. Because as soon as this closes, the current sensor, which we didn't draw, it's also fitted in the battery. It sees current flow, obviously switch the relay off. And because normally, if the system would work fine, this will switch on, and then the other two relays will come on one by one. But obviously, the procedure stops. It doesn't go through because it sees this relay closed when it should be in on position. No, I think in here, I'm not sure. I hope it's not too confusing. Can I have the marker? I hope it's not too confusing. So basically, so it is like that. So first of all, this obviously here we have capacitors and other things. So this circuit energized first, obviously with the resistor. If this is open, it sees that fine. So basically, it does a test. If that's okay, then it closes this relay. Then it's going to close this relay, and this is going to open. So quite comprehensive. Anyway, our problem is that when this is getting closed, it sees current flowing, and this should not be. And let me show you how exactly we've done. So we've disconnected one of the connector. I told you with the dealer tool is differently. They have some special equipment to do this type of test, but we managed to find a way around it, and it's quite interesting to see that it does work. So basically, what are we going to do? We're going to disconnect this, and then we're going to measure the side that comes from the battery. So where does it go, this, Lal? To the heater? Yeah, I think heater, isn't it? But anyway, the thing is, all the electrics on a high voltage are powered on the ignition cycle, and our test proves that whenever we're going to cycle the ignition, we're going to see voltage for a split second. So again, this is going to close. This is stuck. This is our theory anyway. This is stuck. And this is going to close. And for a split second, it is voltage. It is an output. Obviously, when the ECU, the battery control unit, sees that this is not right, it's going to turn this off, and it is going to stop the procedure to energize the complete system. So okay, let's disconnect that. We're going to start with the ignition off. We're going to get hooked to those that... Can you connect it, Lal? Oh, it's a bit tight. Okay, so Lal is going to hold it there. Didi, could you do us a favor, man? When I'm telling you, just cycle the ignition on, please. Thank you very much. So we got everyone. So let's see what it happens. So we're going to cycle the ignition. We ready, Didi? See? No. Okay, 2 seconds. Off. Just wait for a second. Put it on. See? For a split second, we had off again. Are we on? Off, yeah? Okay, on. See? For a split second, we had voltage here. Obviously, is if the system will, because in that connector we don't have an interlock, very important. So and the error gets triggered straight away. So we should not. We should either have permanent voltage in there if system operates correctly, but we don't. And it looks like our problem is in this box over here, which is in the high voltage battery. And for that, we need to drop the high voltage battery. It's quite interesting because the mileage is low, but we looked a bit around. We've done some tests, not just what we did here. We checked the SVM. Basically, SVM checks whether there's any software update. Sometimes it could also be a glitch in the software, and we've seen that in the past. We don't want to take the battery off without really doing all the checks. There's another video of Mercedes EQC. I'm not sure if you saw it. If not, you can watch it on our channel. But based on the checks that we've done so far, we believe it is the right call to take the battery at this stage and get to this little one. So this is how the battery looks like on an e-tron. Obviously, as it is with all the electric cars, the full floor of the vehicle, it is the battery. So what I was saying, what is interesting on our relay issue is that we obviously, based on the checks we did, it seems to be an error with the relay. I would expect to have an error. There's a fault with the relay. I was expect to have an error in the battery control unit, but the error code is actually into the onboard charger. It's very strange why the BMS, the battery monitoring, it doesn't trigger an error code, but I suppose probably they might work differently. Obviously, the onboard charger gets, all the modules communicate with each other. And another test that we've done is in here is the plug to the battery. So with this disconnected, we've done another test. There's no voltage on that connector, and that's because this is the one that energized the pre-charge relay, and this is also the one that sent the error code farther. So obviously, no communication error. How does it look? Lal, are we ready?
Yes, ready.
Everything disconnected?
Everything disconnected. Coolant, high voltage cable, surrounding board.
Time to.
Drop down.
Let's do the honors.
Okay.
Yeah?
Yeah.
Looks good.
Yes, clear.
All clear. And this is how the Audi e-tron battery looks like. So have a look. What's the sealant? But it looks, there's a spray grease or something. But so we are now ready to transport the battery to the workshop batteries, the battery workshop. Whew. This is station. This is where we're going to strip the battery to check our diagram, Lal, and see if we were right in what we have understood about this battery. So where should be the safety box? Should be probably in here, no? In here we expected a safety box. Also the battery controller. In the left or in the right? Take a guess because it's here, should be here. All right. So now we're gonna do a nice cleanup before we'll undo all the bolts and start taking the cover off to reveal the energy within the battery. While we're getting ready to lift the cover, I was talking with Al about possibility of buying a first TV broken, which is gonna be a nice video. Hopefully, if we'll get it and if we'll fix it. But in the meantime, hopefully in here, let's see, ready. So we got all the bolts, and this is, man, this is so good. Which way are we going to go? Is it okay for now? Yeah. There you go. So that's how the Audi e-tron battery looks inside. It's a first for us, isn't it? Yeah. So 2, 4, 6, 12. 12 blocks. And what's the voltage? Funny enough, we haven't found stats for this. On each battery, we usually found a sticker with stats about battery, and here, not at all. I'm looking, but we're gonna find our stats in a second, hopefully. This is the pyro fuse. Take the other one. Yeah, and you're right. The BMS is on the left. So our plan is to take the safety box out and then do some checks while we have it on the bench, and then hopefully we'll have a better understanding what did trigger our error code. So far, it's not yet clear on the voltage and resistance test that we've carried out. But once we're gonna have it stripped, we should be able to do the better check on relays, and hopefully we are going to find something. Let's see, we'll see. Take them out and then we'll carry on from there. We've been doing some tests, and the battery control unit, in the battery housing, we do have the control unit, which is this, and we have the relay blocks. Now, what it seems to me, we have here the pyro fuse, current sensor, the relays, 2 sets of relays, a slightly different setup than what we have previously seen. Now, what we don't see here is the pre-charge system, the system that has to pre-charge the capacitor before the high voltage gets energized. I was hoping that we're gonna get somewhere here, but checks that we've done to the relay, that seems to be fine. We checked the resistance, we checked the pyro fuse, cannot really see anything. And the next step is to get to the onboard charger. So the error code that we're having, it is in the onboard charger, but the control of the high voltage of the energy flowing out of the battery, it happens here through these. And I was expecting that we might gonna see one of those big relays stuck. However, it's not the case. They do operate fine. But it's one element that I cannot see in here, and which is a pre-charge system. As I said, is a first. It's basically this little thing over here. I don't see it in here. This is a diagram from the dealer tool, but you know, it's very generic. It doesn't really give a lot of info. So let's gonna head back to the car and take the onboard charger and see if we can find something in there, because in here so far all looks good. Let's go. Lal, how are we getting on?
Yeah, just one.
Yeah. So the onboard charger is located at the back of the car, and Lal has been busy taking it off. Just came just on time. As you have cooling on it attached, isn't it?
Cooling.
All detached?
Yeah, all good.
Oh, this is quite heavy. Okay, so this is the unit. Let's go a bit to the light. This is the unit that it's registering our error code based on the check. So we are looking for this little one, and we couldn't find it in the battery, and it might be here. We want to take this unit apart to see if we see Have we seen any signs that this has been stripped before?
The wiring connection is loose.
Was it?
Yeah, the clips. The routing is loose.
Really? Do you have a torch? But have been any signs that, because it's very strange, the car hasn't been.
Like this routing wiring is loose.
Just looking, it doesn't look any damage in here. Oh, look at that, the suspension sensor is broken. Was a bit of impact, but nothing really. Do you reckon they put a new subframe? Strange, nothing. Let's see. Let's take the. Yeah, let's take the unit. Now, what we want to take it apart from the bracket. It has 4 bolts that is holding it onto the bracket, and we want to take the cover off at the back. We are looking for any signs of damage, or maybe we can see any. First of all, we're looking for the resistor, for the pre-charge resistor. It's quite heavy. Okay, it doesn't look. Yeah, it's not straight. There's damage to it. 100%, this is not straight. But how come? I mean, there's no marking on the. Man, this is strange. Here is the control unit that is registering an error. That is related with the current flowing outside the battery. So interesting. Let's see the setup. We haven't stripped one of these before. We're expecting to have a pre-charge because, like I said, in the battery, I have not seen the pre-charge, and there's no single vehicle, as far as I'm aware, that will run without the pre-charge. And the reason of the pre-charge is to slow charge the circuit, the capacitors that are helping the engine to turn, because there's a big consumption at the beginning. So if the pre-charge won't exist, there'll be a big spark every time the relay closes. So that's why it's a bit of a slower. I mean, we say a slow charge, but still quite fast. It's a matter of milliseconds. So anyway, we are looking for that system because the error is related with the pre-charge and pre-charge and current high. Now let's get this and then. So here's the section. Try to identify any possible damage to the board, but to be honest, it seems to be very good. Oh. No, it has like a paste. What's in
It looks like some surface corrosion.
it? Isn't it? It's very hard to see. Let me have a look. Oh my god! Oh my god! Look at this, man! Wow! Oh my god! Have a look, Lal. Have a look, man. My god, it's so tiny. That's very,
The sulfation color.
yeah, no, but it's very bad looking like that. Can you bring the light? Yeah, a bit above. This way? No, man. Oh my god, look at that.
The transistor, resistor, all
We've got something. Can't believe in this corner. See? So tiny, but I mean, have a look how many components in here. Definitely things are not right. Oh man, I'm so happy. I'm so happy we found something. I've been thinking a bit what should be the next step today morning, and because there are a few questions. Obviously, how bad it is? Is it this corner? You can even see it. Here's here. How bad is here? How bad is on the other side? But first of all, we like to have a better view, and to do so, let's take it to the microscope. Let's take it to Danny's workshop. We're gonna put it to a microscope where we can see a lot better the damage, and then yeah, see exactly. Because if we look better at it, we can make a better plan. So let's get there. But here is the office, and here are our colleagues, and here is Danny's place. Okay, so this is the mic where. Oh, look, what a view. Look at this. Wow. It's so much better on the microscope. So you see, so much corrosion. Now, what this tells us, it was a bit of a moisture inside. Obviously, big question mark where this came from. But it's not massive because the rest of it quite looks good. But also what tells us in here there is current, because usually the region, if you have condensation, moisture in a control unit, usually the place where it's going to corrode is where there is current. So let's try to clean to see how it's going to clean up afterwards. So this is a spray especially for cleaning. Is it still? See, here looks quite clean. Okay, need to blow a bit with that. Well, clean up quite good, man. But you see, what we had here, it could have caused resistance with the other. Yeah. Because all those holes, they are different circuits, and obviously we had built up in between this one and the other one, so it could easily cause resistance probably and give us. It could be, we're not certain, but obviously this was not right. So our plan is that we're gonna send this to Car Key Solutions in Watford, to the master engineer from there, to have a look at it and probably check the board, because this might be quite a fiddly job, and yeah, probably it'll be a job for him. But let's put a cover on, and yeah, I'll take you there. We have gone through the battery electronics that are inside here, and both safety box seems to be okay. So with those being checked, it is the time to pack back the battery while we're waiting for a charger control unit. Now we're going to try something with the charger control unit. Here is going to be the challenge to see if it works. We don't know, it's a 2024 car, and we will try to do is to program a used one. Among the corrosion that we found, fortunately we did not manage to strip farther than we wanted to. Apparently the board is glued onto the body, so it's not designed to be stripped. So we'll have to see how it's going to go. It's an interesting one, but at least we know this is covered now. It is the time to put everything back together. We test the relays. Interesting concept. Another interesting concept with two sets of relays, but yeah, I think we found new things every day, isn't it? This is interesting in our job. But let's see how everything is going to go. At least we know high voltage battery is fine. So we're gonna put it back. We don't always film real life as we go along because sometimes it's a bit difficult. So we've done a bit of work and I want to tell you what we did. So we got some good news, some not so good news. So the good news is that on a 2024 Audi e-tron, we can use a used charger control unit if needed. So that means the programming went through fine. The bad news is this. We are back to square one. So the pre-charge current too high error code is still in there. Now, I've done a test plan with the Audis. I run some other checks, try to find some more information. So the error is still on a dash when we're cycling the ignition. See, we cannot get rid of that. And it's a bit strange that we have that error code because I was expected to be associated with something else. Now, this error code, to me, it was telling me that there is an issue on the pre-charge side of the high voltage system. Whenever the pre-charge try to kick in, the current is too high, so maybe one of the relay is stuck in the on position, something like that. Although after we checked that, we've seen the water in the inverter, I mean small condensation. To be honest, I think that control unit is still operates. We're just gonna see with the customer whether he wants to keep it, because yeah, the new one we can it can be returned, if anything, it can be used on any car. But there was a bit of condensation, however, that was not the cause of the issue. So there's still something else on this e-tron, and it is a bit shocking because with this error code of the pre-charge, I would have expected to see something as well. Let's do this. Yeah, let's do the installation
Can I
test.
switch it on?
Sorry?
Switch it
Engine
on.
off, yes, switch the engine off. So basically, we've done more checks, investigated a little bit more, and we found something rather surprising. Very, very surprising. Because it looks like this high voltage current, what actually says, when the, where is our, you can find, yeah, disconnect and prepare to do the installation test. I want to run in here a test, an explanation. So basically, when the circuit is closed and the battery is putting out current, there is a huge current draw. So what this tells us, something is using a lot of current. And this something could be like a leak. However, we have no leak fault. And that's why it makes a bit, you know, the diagnosis process. Sometimes, I mean, is not uncommon and unheard of. The error code, it doesn't take you directly, it gives you an indication. This is like in everything in diagnosing the car. And then you have to put together the puzzle bits and find the alley towards the problem. Now, yeah, while we thought it's gonna be something with the pre-charge relay or one of the relays, something not right. It's not the case. Everything seems to be all right. Actually, we didn't even manage to find the pre-charge because on this Audi seems to be built into the charger. So it's a bit of a different system. But we checked those relays and they do operate okay. However, it seems whatever is going out somewhere is drawing a lot of current, and that's why it says current too high, because here is drawing too much current. Now let me show you what we've done, because we kind of finding our alley towards getting the e-tron fixed. So we are now doing an isolation test, and if you remember, isolation test, what it is basically making sure the high voltage circuit it's separated from the vehicle chassis. And this is our test. And to be honest, initially, only based on the error codes, I did not suspect, is it this connector?
All three. One from this side.
So we have 3 connectors.
Yeah, heater and the compressor.
So basically, what we should have if everything is fine is a high resistance. The low resistance is mean continuity between the high voltage system and the vehicle ground. And look what we have here. So again, this is not good. What this tells us, this side of the high voltage circuit, so those 3, they go into the junction down. Yeah?
And downside.
Yeah. And then probably, so is this orange over here, it'll be quite difficult, so we have to strip more going forward, yeah. And the isolation in here, it is low. So this is our current draw that is triggering the current high error code, and obviously stops all the high voltage system from working. So what is the plan now?
First we have checked this side, otherwise back side near the charger control module.
Yeah, I think we might be in a position where we have to, because obviously we don't have accessible, do we have accessible all the cables?
No, it's under the chase and the top side of battery.
So we might need to
Drop the battery again.
Yeah, listen, yeah, it's a new car. We just seen now this type of pre-charging system. Obviously we have the support and some documentation, but purely on the error code, I was not thinking initially we're gonna have something like that. So we're gonna start stripping more to get better to the.
Here one joint connector. If you remove the battery, maybe.
Yeah. So we're gonna take the battery out, the 12-volt battery, make a bit more room, and basically chasing up this wiring to see exactly where we have that current leak to the chassis that is triggering our error code that stops this e-tron to go. Oh my god, I want it out, man. Yeah. Okay, let's get on. So do we have now clearance enough here?
Yeah.
So what we have done, Lal has dropped a bit the subframe. This is the subframe. So we have lowered the front motor to get to this connector, because now we want to do some measurements in comparison with the rear motor. So as I said earlier, there's a Y cable that comes from the battery and then goes to both axles. And see this cable here goes to the rear motor and front motor. So there's no other joint, and it was quite difficult to do checks. So what we are going to do now is hopefully a measurement that is going to tell us where the problem is on this e-tron. Where's the multimeter? Are we getting close to it? You got that feeling right?
Yeah.
Loud that the problem is on the front. So, yeah. We're gonna check here, and then we're gonna disconnect the front motor. We wanna see whether there's differences, because when we're gonna disconnect the front motor, we'll basically be able to evaluate the rear motor separately. The measurement that we're gonna do now is basically taking in consideration both motors. So let's see if any changes here. Let's do also on the diode.
0.0050.
The other way around. Same. Okay. So this measurement is taking in consideration both of the front axle. If we disconnect the front motor,
Yeah,
we can
separate.
measure separate the rear motor from the front one. And then, can you see the, no, I think from here, yeah, it's very, So this is one section of the Y cable. What are we gonna measure first, the cable or the?
We can check from here or there.
So basically, measuring this side of the Y is going to the back motor. Let's see what we have in here.
First,
Let's see.
open the
Open loop.
yeah. Okay, check diode mode one more time.
Yes. Okay. It might go down to 0 if.
It's open.
Okay. So let me explain you what is going on. The measurements are different from what we measured here compared with what we measured there. Now, it looks like there's a difference. Let's see if we see anything in the front one. Is Lal right that there's something wrong in the front inverter? Did you know something all along and you didn't want to say? Lal.
Yes.
Did you do that? Is it that? Let's see.
Resistance or resistance.
In theory, in here, we should have same reading as this open loop. But we don't.
Sure.
But we don't. And it looks like we have a problem in the front inverter. Let's do a diode mode. Hold on. Yeah.
Same reading.
The other way.
Reading we receive on back side.
Something is not right. And something is not right with the front inverter. I think this will be our high current.
Yeah.
So whenever the system wants to pre-charge the high voltage circuit, the front inverter is drawing too much current, and therefore the system shuts down. Feels the current draw. So it must be like we should not have resistance between those two terminals, the input towards the inverter. So definitely something bad inside. But does it look like it's been hit or something? It's very
Look
strange.
like good.
Huh?
This look like good.
The damage only seems minor in the front. But with this measurement, we clearly establish the problem is in the front axle motor. So it was the right call, Lal, to start there. So because we couldn't drop this connector, see, we had to make a decision whether we're going to drop the rear axle or drop the front to disconnect and be able to do individual measurements. But with this type of, by doing so, now we pinpoint that we need to get into the front inverter. So Lal has been a bit busy. So we decided in the end not to drop the full assembly because we have a bit of space on the top.
The blower casing,
Yeah.
we can.
To be honest, it's a bit surprising because they are so compact. I would have thought
But if
it's
you
okay.
remove the blower casing, there's a lot of space.
There's a lot of space. So basically, just want to show you the layout here. So we already dismantled it, but we want to show you how it looks like. And now, obviously we already had it out, but we just put it in situ. So for you to understand, can you pull it out, Lal? So this is how the inverter looks like on Audi e-tron. And then look, it sits on top of the electric motor. So those are the three-phase connectors. Still a bit tight, but Lal managed to get access. But what about the connector? Do you have to drop the subframe together?
No. Only the problem with the this casing is hitting with the heater core.
So you have to drop a little bit.
Little bit only.
Okay, but what about this one?
This we can remove from there. Before we already dropped the
So,
suspension.
but you still have to drop. So you still have to drop a bit of suffering because the clearance is not there without lowering it at all. Anyway, so can we run this test now? Just where is it?
Connector is here.
It's here. Oh. So can you run our test again? Because you see, sometimes when you take it off, you check it again and it's not. The problem is not there anymore. Okay, same. So this also, it is a component, as on many vehicles, that has cooling running through it. So in and out, obviously to keep it cooled, very, very important function. Lal has already taken the cover off. Let's reveal to see if we see anything. By strange, so the thing is, it has no damage, but you never know whether it could be down to the impact, something has gone or surge in the power. Very hard to tell. So this is the cover, and this is the electric board. So what do we have in here? This will be the control unit itself.
This is memory unit.
Yeah. So this will be the memory unit that holds all the operational data of the unit. This is the power side, isn't it? So where do we have the three-phase? Three-phase underneath. So somehow gets in here and gets transforms. The IGBT should be here.
No. Here it's not look like IGBT. Maybe.
No, maybe this side. No. So probably takes those boards apart. But what we're gonna do now, we're gonna take this unit to Car Key Solutions. They always help us with electronic components repairs. Car Key Solutions also specialist in car keys and vehicle security, so a good name to trust if you need any of those services. Let's put the cover on. Yeah. I'll take it to Car Key Solutions in Watford, and let's see, hopefully we might be able to even fix it. We don't know. There's definitely no physical damage, but let's see, because sometimes with things like this, you might not even see anything. I don't know. Yeah, for now we're gonna put the cover on and send it to Car Key Solutions. We're gonna put the Audi out for now, and then hopefully we're gonna have some news, but I think we're making good progress to get the Audi running. And we are now in Car Key Solutions Watford branch, the place that assists us whenever we have some electronics repairs needed. Also, the place to go for car keys and vehicle security. Now, with our inverter stripped on the bench, we give them the symptoms and the measurements that we've done already. They've done some checks, and I actually found a problem on the inverter. So we've got the microscope looking on those two components, and those two components, it seems that they were defective, and now they have been replaced. So we have the old ones over here, and I'm just going to show you now how do they measure and how they not supposed to measure, so the value. So this is one of them. This is the measurement that we do, and this particular one is faulty, so we should not have continuity. And now we're going to measure the one on the board. See, all good. Now those two little parts are called IGBTs. inverter gated bipolar transistor. So similar parts, but obviously much bigger power are used in inverter. So basically are just some power switches that they go on and off, on and off. And apparently it looks like one of them is gone faulty, but we replaced both of them to be certain since we've got in there. And have a look now when we do our measurements, open loop. So it looks all good now. Obviously the cover has to go now back on the unit, has to be sealed properly, watertight, and then we'll be ready to have it back on the car. I'm very eager to get this Audi running, and this is quite good. What do you say about that? Because we managed to fix this inverter with I think probably around a couple of pounds, a few pounds, the parts, where you put it in comparison with a new unit or even a used one. Although a used one is going to be a bit of a tricky job because it has immobilizer function integrated. So definitely much better value to have just the component that they've gone faulty. Now, the reason why did they gone faulty? Sometimes it could happen during an accident, a signal trigger. Is very hard to understand. Obviously, the only thing that we can do is put it back on the car and see, but we don't see any crash data in any other control unit, so it should hopefully run fine, but time will tell. So for now, we're going to leave the engineer to put everything back, and we're going to get the unit back on the car, hopefully getting the Audi running. So the inverter is pretty much all in.
Yeah,
we're putting the coolant. We're going to connect everything. We have to bleed the system, and then hopefully, yeah. What is that for?
It's going inside the dash.
Will it be the heater in there?
Maybe some electric heater or something inside.
Yeah. Okay. But hold on, there's a heater also.
This normal heater outside is for one for the compressor. This connection is directly go to the dashboard side.
Interesting. Anyway, hopefully we're gonna get it.
Yeah.
Okay, so we need to connect the battery. We need to connect the diagnostic tool, because before we try anything, we want to make sure the system is bled. Those components are so sensitive to temperature. If hopefully the Audi is gonna start to operate, we don't want to get it overheated and get it damaged. So we need to connect with a diagnostic tool to run the bleeding. We are now connected to the car, and of course we're going to have many error codes because the components, they've been disconnected. So what we're going to do, Abi was about to fall over, but okay, he recovered. So yeah, a lot of error codes expected. Our concern is in the onboard charger. Yeah, many error codes. And the problem is only going to come when we try to turn the ignition on with the foot on the brake. Actually, on this Audi e-tron, you just put a foot on the brake and try to engage the gear. Ready should come on, or at least will try to come on and will trigger the error code. So let's clear everything. We're gonna do the procedure of bleeding the cooling system. Let's see, so you have many errors clearing. I remember we had some radar codes, isn't it?
Yeah.
Yeah.
And the AC.
And AC. Yeah, we have to regas the AC.
Yeah, I already regassed it.
Ah, it's regas now. Perfect. Scanning all the error codes and clearing. Is the time to fill the cooling circuit. Is a procedure that is going to run for good 20 minutes probably. Switch the ignition on. So basically it's going to run the cooling pump to bleed system. Okay, so the system is actually taking 7 minutes. So one important aspect why this bleeding is needed, because classic engine they don't need, but the way that system is designed with so many control units all in layers, the cooling trails they quite thin, so it's easy to get air pockets, and then that will then cause overheating. So basically what the pump does, it runs through the coolant, and by running the coolant, it should push all the air out. This procedure takes 7 minutes, which is not too bad because there are procedures that it can take 20-30 minutes. So this is very good. We've got the level up, and hopefully in a few minutes we should have this completed. Once it's done, we're gonna get to our main thing. We want to see if the ready finally comes on. We are nearly there. Hope so.
Yeah.
Or at least. Okay, we still have to put the, what's the fan box, yeah?
Yeah, the blower case.
The blower case fits here on top, but we haven't. Yeah. Look, one thing. Do you know where the engine is on this, the combustion engine on this Audi e-tron? Would you know where it's located? Here. This is the one that makes noise.
Speaker.
Huh?
The speaker.
The speaker. This is the combustion engine of an electric car. Well, just the noise of it. It's been bubbling quite a bit. The level went down as expected. So now the system, it should be bled. It is the time that we've been waiting. Is there anything more to this story? Or that's it? Let's see what error, or hopefully no errors, we have when we put the ignition. So we have, but you know what? I remember even with the ignition on before, the electric message was coming on straight away. So yeah, we have the steering is on. So we have the traction control light. We know we have the airbag. Radar. Oh, we still have an error with the car. Let's see what errors we have. Any distance warning, we know that. Nerve-wracking. Put on the brake. Oh no.
It's ready.
We have ready. Woo! We have power steering. Audi Presense. What are the error codes? Traffic light, yeah, camera, a lot of things. Steering fault. Drive system fault. Okay, well we do have. Is it all up in the air?
No, no.
Can you put it up in the air?
Yeah.
Yeah. The engine has started. You can hear it. So the combustion is. It's quite noisy without. Where's the parking sensor? Where's the parking sensor? Here. We have drive. That makes a lot of noise, huh? Without all the covers on, the engine sound is noisy. We've got good progress finally. So it looks like those transistors, they made the trick.
Yes, sir.
Looks good. So we have quite a few components to put back. We need to put a battery on charge. It looks like we're gonna need to do the radar calibration, obviously some other things, but the main thing is that, let's start again. We do. So the ready comes and drive system, we still have some error codes, but we have to see why. But we have drive, we have ready coming on, headlight range. So we also replace one level sensor at the back, which might need calibration. Some more error codes, but we do have the electric motor operate, the ready comes on drive system. We need to scan that again, but yeah, let's start putting everything, scan it again, and then I think we're gonna have the Audi out soon. I'm so pleased we managed to fix the inverter with just by replacing the components, but obviously the test will be to run the car, because it could well be that something else has caused those to fail. or it could be from the accident. We don't know, so big question mark. But so now we're gonna scan again. We see any other error codes. We want to take it out in a drive test. Then we might need to do some more calibration, but it looks positive. The Audi is on the way. Because the high voltage battery was quite low, we decided to have it on charge before we do the first road test. We have it charged now, and it is the time to drive the Audi. Let's see how it's behaving on a drive. The charging cycle went through fine, which is very good to see. We're gonna leave this here and let's get out in a drive test. We've got a bit of charge. It says 89% and 165 miles. But you know why? Let me show you. Have a look in here. Touch the AC button. 269. Imagine how much energy the AC is using. And it's good. We have no error codes. Already comes on. Let's drive. Drives quite nice. No? Smooth. Look at how the battery starts to look very good. Battery well balanced, but it's kind of expected of a car with this mileage. All the lights went off, so it looks like one of the error codes was saying that still needs a bit of driving for another error to self-clear. We'll run a test. We want to do a few miles in it, make sure that the operation of all the components is good. The charging control unit, it does operate good, the unit that we initially replaced. And I think we're gonna leave that on, because on the other one we've seen some corrosion. It wasn't much. We know for certain that was not the cause of the problem. The cause of our problem were the transistors in the front motor inverter, which seems to operate correctly. This is what I like in comparison with the combustion engine, the acceleration. I also like combustion engine because I always been into cars, and always that's how I started being a mechanic, fixing combustion engine cars. But I do like the technology of the electric cars. Do you? Have you ever been driven an electric car? Because I see so many opinions, pro and contra, about electric cars. People reluctant, but I'll be curious to see how many people that are reluctant towards the technology of electric cars have really driven an electric car, because there are obviously a lot of positive on electric cars also. I don't know, leave me a comment if you've driven one, or if you haven't driven one and you don't like an electric car. Why is that? I'm so keen to find out. Always talk with people about this topic, and you know, there's one key subject that's in this discussion, and to be honest, I had it with several drivers of electric cars, and because there were company cars, they would say if they would have to make the decision to get an electric car, they wouldn't have done it. However, they were quite pleased about the performance and driving and so on. So it's quite interesting, because sometimes people, they made an opinion based on assumptions, not necessarily facts. I mean, this is a situation that I have discovered in several discussions with electric car drivers. Anyway, let's get back to our e-tron, which today seems to drive beautiful in sunny London. We're gonna head up on M1, try to do a good road test, check all the components. What's the temperature in the battery? 8 degrees, quite low. What's the outside temperature? 9 degrees. So now the battery needs to be warmed up by the coolant system. It doesn't need cooling down. Quite cold. Again, temperature that a battery should operate should be optimal between 15 and 30 degrees. So now it's a bit cold. what we probably want to do, Abby, we want to go in the onboard charger and also the inverter. I want to check the temperatures there. So how are the temperature reading?
So stored under 20, maximum 30 for the stated temperature.
Perfect, perfect. So temperature stats look good. I've reset the chip computer, and look, this car, I mean, since we have it on cruise control, we haven't done many miles, only 2 since I reset it. It does 3.3 miles to kilowatt. That's a bit low. Which one we had it the other day?
Jaguar
Was
with 5 without heating on.
close. We don't have any heating on, no? No. The Jaguar was doing close to 5, yeah? Let's see, do about, I don't know, 10, 15 miles to see. It was, yeah, we were showing quite good, the Jaguar, wasn't it? Close to 5. It doesn't do that in real life, but here we also on cruise control, so without any consumers of, and the one that uses the most energy is the heating. So if you can bear the cold, you're gonna drive a longer way. Well, it's not too bad today. Like I said, it's a bit sunny, about 10 degrees outside. So we're probably gonna put a few more miles in it, just to make sure all the components are working fine. We might do another battery cycle. So after we're gonna use the battery, but it shows 230 miles. So that will be a long way for us to drive. We won't do that. But yeah, we're just gonna do this extensive test, probably, I don't know, 30, 40 miles, and head back to the garage. So we've done in total probably just over 100 miles, and the Audi runs fine, no issues, no warning lights on the dash, and we are getting ready, handing the car over to the customer. We just done the last checks, all seems okay. So the Audi is ready to go. So it seems like the fix we did for the electric motor inverter has worked. Now, with this being done, there's one thing to go through. What was the cost in getting this Audi e-tron fixed? A car that came from auction. This will also be interesting is if this was a good purchase. Do we know the price on the auction? That would be a good thing if we can find out. Let's go to the board and do a review. So this e-tron was an auction car with non-starting. Initial diagnosis revealed that on a pre-charge, when the high voltage system was trying to set alive, it was shutting down. So you're setting live for a bit and then it was shutting down. Our initial diagnosis pointed towards a possible problem in the pre-charge system, for which we have taken the battery out. We haven't seen any problems in there. We had an error in the charger control unit. Then we took the charger control unit. So this was the module that was triggering the error with the pre-charge. We took the module off, we took it apart. We couldn't see anything physical other than corrosion in one section. Do you remember which one it was? Anyway, if you remember, so this is slightly distorted than the other one, than the new one. Anyway, because we've seen that bit of corrosion, we said it might be a good thing to replace it, because electrics and water, they don't go well together. Although afterwards we realized the problem was not from the charger control unit, because we managed to use a used part and get it programmed, and it wasn't that expensive. We replaced this, then obviously move forward, because this has not fixed the problem, done more checks, and with the measurement that we've done on the motors, we pointed that it was a problem on the front electric motor inverter, which we took apart, and then we found those tiny components, which are like switches, and one of them, it was defective. Now, what was the cost to fix this Audi? So we've started with initial investigation, for which we've charged 120 plus VAT. And then we had the charger control unit. So we managed to get this a used part. Do we know how much was the new one part? New? 1800. So we managed to get this part for £650. Was this plus VAT or plus VAT? And then we set a cap cost for the job when we given the initial estimate. It was a bit tricky, but was also, I think, very interesting that we went through a lot of components. And for all this, we charge 1800 plus the VAT. So this is going to take us to a total of 2,400, 2,570. Am I correct? Is the math thing doing well? It will know in the comments. Leave me a comment. I've done it quickly, so I think this will be the total on this repair, to which we made the e-tron 2024 running again. It'll be interesting to see how this adds up with the buying price and whether this was a good deal or not. But I think, hold on, we missed the most important parts, that we fixed the parts, the car, the IGBTs, yeah? Those two parts, the most expensive item. So those parts were £2.50 each. So we have to add £5 more on this total repair. Do we know how much was the inverter? No, I'm pretty sure it would have been over 1,000, if not more, definitely. So in the end, probably this would have fixed the problem. We only replaced the charger controlling asset due to the corrosion. But now the e-tron is fixed. It's ready to go to its owner. We're going to find out, and we'll put it in a comment, how was as a deal overall and whether it worked out well. I hope we managed to save some money overall with the whole repair. And if you like this video, don't forget to like it. Leave me a comment. What do you think was interesting about it? And subscribe to our channel, because we're going to have weekly interesting videos from the workshop. Interesting repairs translated in video. Also the notification button, so you're always notified when the next video comes up. I will see you soon.